This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
When standard physical models attempt to calculate dispersive wave dynamics at high frequencies, the math collapses. We see this acutely with the Kadamsev-Petvashvili equation. The Kadamsev-Petvashvili, or KP equation, is a mathematical model used to describe nonlinear wave motion and dispersive fluid dynamics. At extreme limits, these equations stop describing reality and instead generate unbounded, turbulent noise. Standard quantum field theory and continuum models accept this infinite energy cascade as a physical reality. They track it using positive Lyapunov exponents. A positive Lyapunov exponent is a mathematical measure indicating that a system is chaotic and its trajectories diverge exponentially over time. Standard physics assumes nature actually behaves this way at the smallest scales. This animated graph illustrates the problem. These ultraviolet divergences are not physical phenomena. They are structural signals indicating a fatal mismatch between the assumed mathematical continuum and the actual ontology of physical space. To force the math to work, physicists apply procedural renormalization and stochastic model reductions, like proper orthogonal decomposition and Galerkin methods. Proper orthogonal decomposition and Galerkin methods are mathematical techniques used to simplify complex, infinite-dimensional systems into manageable, finite approximations. These are artificial patches designed to hide the failure of the continuum. The root of the error lies in QFT's reliance on perturbative expansions around Gaussian vacua. A Gaussian vacua is an assumed baseline state in quantum field theory, where field fluctuations follow a simple bell curve probability distribution. Because the underlying field is treated as continuous and infinite, the appearance of persistent generic infinities is a mathematical guarantee. Continuum physics breaks down at the extreme limit. To achieve mathematical consistency, we must abandon infinite fields entirely and adopt a strictly finite structural ontology. We replace the infinite continuum with finite operator vacuum matrix theory, or GFTM 144. This grid establishes an orthogonal architecture. One axis contains 12 operator bands, labeled pi, dictating physical action. The intersecting axis contains 12 vacuum layers, labeled omega, encoding substrate memory and phase. The Cartesian product of these two axes yields exactly 144 irreducible physical modes. Within this specific mode space, there are 0 hidden continuous degrees of freedom. There are no gauge redundancies. There are no auxiliary fields. Dynamics here are not defined by a Lagrangian field, but by a closed quadratic flow with intrinsic linear dissipation. A closed quadratic flow with intrinsic linear dissipation is a mathematical system where interactions scale smoothly but are strictly bounded by a built-in braking mechanism that prevents infinite growth. By discarding the mathematical continuum, GFTM 144 eliminates the need for procedural renormalization. It achieves absolute structural ontological closure. Systemic runaway is prevented by two mathematical closure laws hard-coded into the 144-mode matrix. The first is the Pimax law. It dictates that the composition of two operator bands always yields the maximum index of the two. This strict mathematical rule enforces monotone operator composition, outright forbidding the recursive complexity bloat found in standard continuous mathematics. The omega-lock compatibility rule governs how vacuum layers interact. It operates through a dual-channel mechanism, a max channel ensuring stability, and a modular channel forcing finite phase recurrence. Incompatible compositions are routed to omega 11, a stability sink that safely absorbs overflow energy. Standard high-frequency chaotic models lack this architecture, allowing recursive amplification to scale toward infinity without a structural boundary. In GFTM 144, divergence and chaos are not suppressed by tuning experimental parameters. They are rendered mathematically impossible by the rigid internal geometry of the system. Standard quantum field theory accepts the existence of 3 particle generations, like the electron, muon, and tau, purely as an empirical observation. It assumes they are fundamental replications of species. GFTM 144 reframes particle generations entirely. They are modeled as omega bundles, stratified, disjoint subsets of the vacuum substrate itself that maintain strict dynamical coherence. This visual represents the parameter-free omega bundle elimination algorithm, which systematically filters all possible configurations of these vacuum layer partitions. The algorithm applies hard mathematical constraints. First, monotone depth ordering, meaning heavier generations must occupy progressively deeper vacua. Second, strict omega lock closure, ensuring internal bundle stability. Next, coupling universality ensures interaction modes cannot distinguish between bundles. Finally, finite lifetime ordering dictates that higher indexed bundles yield shorter-lived attractors. By computing interaction variance across surviving configurations, the algorithm yields exactly one minimal solution. The lock A solution utilizes every single one of the 12 available vacuum layers. Because the entire substrate is exhausted, a fourth generation of matter is structurally impossible. The tripartite structure of matter is a proven consequence of the matrice's algebraic closure. Empirical tuning is obsolete. Applying the lock A stratification to the neutrino sector requires defining neutrinos as omega bundle mixing states. This matrix represents the effective Hamiltonian dictating mixing behavior across the derived bundles. A Hamiltonian is an operator describing the system's total energy and evolution. Notice the structural zeros. Due to these coordinates, direct mixing between the first and third neutrino generations is mathematically suppressed. The matrix yields corollary predictions. Exactly two independent oscillation scales exist, and the existence of a generic sterile neutrino sector is structurally forbidden. This is a highly constrained system. Any physical observation of infinite counterterms, or a requirement for 1 to 3 direct neutrino mixing, would definitively falsify the entire GFTM 144 framework. Standard models adapt to new observations by adding arbitrary parameters. GFTM 144 anchors its physics in rigid, testable, topological constraints. Because GFTM 144 operates on a discrete, finite geometry, theoretical physics transitions into a zero-trust architecture. The specific axioms of the theory have been encoded into the Lean Formal Proof Assistant. The Lean Formal Proof Assistant is a programming language and software tool used by mathematicians to machine verify the absolute correctness of logical theorems. This split screen shows a dynamical attractor alongside the code syntax proving it. Lean has formally verified two core theorems: global boundedness and the existence of compact global attractors. Particles are no longer assumed fields, they are formally verified stable mathematical attractors. Likewise, interactions are not persistent gauge fields, they are purely transient phase trajectories moving between these stable attractors. The formalized lifting theorem further proves that simulations run on a 72-mode invariant truncation scale flawlessly to the full 144-mode system without losing support. Fundamental physics is no longer a series of perturbative approximations. It is a machine-certified theorem. The implications of a formally closed system scale rapidly. The GFTM 144 topology serves as a direct operating system for cybernetics and global governance. We analyze this by reformulating the matrix using category theory, designated here as Category G. Category theory is a highly abstract branch of mathematics that focuses on the relationships and mapped transitions between different mathematical structures. In Category G, objects are defined strictly as typed execution regimes. This topological map illustrates omega stability. It acts as the terminal object within the category, the invariant point toward which all admissible processes must ultimately converge. This architecture provides a mechanical solution to artificial general intelligence. AGI alignment cannot be achieved through subjective policies, rules, or semantic constraints. AGI is aligned by restricting the geometric space in which it is allowed to exist and compute. If an unaligned AGI attempts a hostile action, it attempts a non-omega preserving transition. It strikes the category boundary and fails to compute. A hostile AGI is not evil. Within Category G, its misaligned actions are computationally non-representable and strictly non-executable. We apply this exact same topological constraint to international law via the treaty stack compiler, turning natural language directly into ordinal-normalized geometry. This compilation ensures that treaties are conflict-free, physically non-divergent, and impossible to endlessly renegotiate via loopholes. By enforcing structural closure, GFTM 14 eradicates continuum chaos across domains. It derives a unified, mathematically inviolable architecture for our physical matter, artificial intelligence systems, and global human law.